Wow, we have made it to the third of 3 videos on methods of preparing salts. This is the final one, thank goodness, and this is a video looking at how you produce a soluble salt, so in other words a salt which does dissolve in water, but using, this time, a soluble base, so a base that does dissolve in water. And we're going to look at the reaction which could occur between sodium hydroxide and hydrochloric acid. This is a neutralisation. We've clearly got an acid, hydrochloric acid, and the base is sodium hydroxide. It's a water-soluble base, so you could also refer to it as an alkali. And in this reaction we produce sodium chloride and water. So this is a preparation technique which we could use to produce pure sodium chloride. And the name of the technique is called a titration. And in another part of your course you will look at titration calculations, but today we're just looking at using a titration to prepare a salt. We're not looking at doing any kind of calculations. So we are going to react exactly the right amount of hydrochloric acid with exactly the right amount of sodium hydroxide to just produce sodium chloride and water. We don't want either of our reactants to be left over in the mixture at the end. So we have to react these together in exactly the right proportions. Now that's quite tricky to do practically, so we need to use some very refined, some very specific and specialised practical equipment. And you can see here that the first bit of apparatus that I've got on the screen is a burette. Now a burette is a wonderful device for measuring volumes of liquid very precisely. So what we are going to do is, and it doesn't really matter which way round you do this, but I'm going to put my sodium hydroxide in the burette. I'm going to do what's called charging the burette, which means filling the burette and also ensuring that this end of the burette is full of liquid. So the first thing I'm going to do is charge my burette with sodium hydroxide. I'm then going to measure a specific amount of hydrochloric acid using another piece of apparatus called a pipette. Now a pipette is a piece of glassware with a sort of bulb in the middle of it, and it is used to only measure a very specific, in other words one amount of liquid, or one volume of liquid. So you'd put the pipette in a beaker of liquid like so, and on the top of here you'd have some kind of pipette filler. So it's usually a sort of rubber device which sucks the liquid up into the pipette, and you suck up just enough to get to that line there. It measures it very, very precisely. So it is much better than using a measuring cylinder. So I'm going to say use a pipette to measure, and I'm going to choose a specific volume of hydrochloric acid, 25 centimetre cubed of HCl, and pour into this device here, or this is not a device, this piece of glassware, this conical flask. So pour into a conical flask. So I apologise for the quality of the handwriting. So I'm going to label that as HCl. Now it doesn't really matter whether you put your HCl in the flask or if you put it in the burette. The reaction will still work. Now the next thing I'm going to do is add 3 drops of an indicator. Now you need if you're describing this in the exam, to mention a specific indicator. So I'm going to mention my favourite, which is phenolphthalein. Always a little bit worried when I do that I spell phenolphthalein correctly. So I hope I've done that right. Phenyl pH phthalate. Now, phenolphthalein, when it goes into an acid environment, remains colourless. So I'm going to note that down. The indicator stays colourless. Now I'm just running out of space a little bit, so I'm going to try and move this up here. That's working quite nicely. So let's just move to the side. And now we're ready to start the experiment. So what we're going to do is we're going to add the sodium hydroxide from the burette dropwise into the HCl. And you should know the colour change for this indicator. So when phenolphthalein is in an acid environment, it's colourless, but when it's in an alkali environment, in other words, when it would be in sodium hydroxide, it would be magenta, a beautiful pink colour. So we are just about to add our sodium hydroxide from our burette, but before we do that, we're going to note the start volume. We're going to do that to 2dp, and there's another video on that. So we're going to 2dp, we're going to actually measure it to the nearest 0.05 centimetre cubed. So we're then going to add our NaOH dropwise. So in other words, it drips in, not sloshing in a huge amount, but it slowly drips in from the burette, drop, 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 and we add it until a first colour change is observed. Now, the colour change has to be permanent. So add the sodium hydroxide dropwise until first permanent colour change. I remember my teacher at school saying first faint permanent pink or magenta. So it stays magenta. Now, at that present moment when you've just reached that point where you get that permanent colour change, you should, in theory, have a mixture, a perfect mixture of sodium chloride and water. But our mixture has also been, I was going to say poisoned, but has been laced with indicator. And if we're making a pure sample of sodium chloride, we don't really want there to be any phenolphthalein in there. So what we're going to do now is we're going to repeat the experiment. So part 6 is repeat, but we're going to do it without the indicator. So what we should have done, and this is possibly something I should have mentioned, is when you've got this first permanent colour change, okay, you should note the volume on the side of the burette, because that then enables you to tell how much you finished with and how much you started with, so that enables you to tell how much sodium hydroxide you added overall. And so repeat the experiment without an indicator and add the same amount of NaOH as before. So at this point here, you've got a lovely solution. I'm just playing around with the icons here. Lovely solution in here of sodium chloride and water. We don't want the water, we want the sodium chloride, so what we do is we transfer that solution into an evaporating dish, very much like the one we used in the last experiment. We put the evaporating dish above a Bunsen burner, and just like the last experiment, we evaporate off half the water. Okay. We then, once we've evaporated half the water, we can pour the liquid into a crystallising dish, which is rather fancy to be honest with you. So a nice glass Pyrex crystallising dish, or to be honest, you could just leave it in the evaporating basin without the Bunsen burner and let the remaining water evaporate. Again, we do that for the same reasons as we did with the last one. We evaporate only half the water rather than all the water, just in case our crystals decompose with excess heat. So our final steps, I'm not quite sure why the number 4 seems to float around. When I move the screen, that's quite interesting. Final steps, so number 7 this time. Pour the mixture into an evaporating basin. And evaporate half the water and leave the remaining half to evaporate naturally. And we do that obviously, as I just said, in case the crystals decompose on excessive heating. So that concludes our look at the 3 methods of producing salts. If when you've been watching these videos you've been thinking, how do I know if the salt is soluble? How do I know if the base is soluble? Good, I hope you are thinking that. I'm going to answer that question in the next video.